Hey everyone, so you clicked on this video because you're interested in learning how to find the inverse of a matrix. Well, in this video, I'm going to do exactly that. Now, if you don't know the basics of how to add matrices, multiply them, or even find the determinant, click on the link up here and go through those basics and then come back to this video to find out how to find the inverse of a matrix. Now, if you know all the basics of those different concepts, adding, subtracting, finding the inverse, and you're looking for another challenge, then click on the link up here where you'll see me solving some word problems using matrices. Now, if this is your first time coming to my channel, my name is Peter. I make math tutorials that are easy and fun for anyone to get to learn these different concepts. So consider subscribing to the channel, liking the video, and sharing it with someone that'll find this content useful. Having said that, grab your calculator and let's get started. So let's start off with the definition of an inverse of a matrix, and it is a matrix which on multiplication with the given matrix gives the multiplicative identity matrix. So there are two things in that statement. The first thing is multiplication. So whenever you're trying to figure out the inverse, we're going to be dealing with multiplying the matrices. We're not going to be adding or subtracting them. So this gives you an identity matrix. So now the next question is, the second thing is, what is an identity matrix? So identity matrix is pretty much a matrix where the diagonal that is decreasing from left to right, those values on that diagonal are just ones, and all the other values are zeros. You indicate an identity matrix using the letter I and a subscript. That subscript will tell you the size of that matrix. So a 2 will be 2 by 2. I3, subscript 3, means it's a 3 by 3. Notice this diagonal here is just ones. Everything else is, all the other values are 0. I4, it's 4 by 4. I5 is 5 by 5. So now going back to the definition, after looking at what an identity matrix is, so how do we get the identity matrix? We multiply the two matrices. So here, if your matrix A, you have matrix A and you multiply by the inverse of matrix A, you should get the identity matrix. So if you have matrix A, it is a 3 by 3 matrix times the inverse of that 3 by 3 matrix, you should get an identity matrix. So when you multiply the given matrix and its inverse, you get the identity. We called that the multiplicative inverse. But what really is the multiplicative inverse? So I'm going to use an example from numbers, and then we're going to be able to connect that with matrices. So if you have a number A and you multiply by its reciprocal 1 over A, that product is going to give you a 1. Because A times 1 over A is going to be A over A, and that equals to 1. A reciprocal is the inverse of that number. So this is how we understand an inverse or a reciprocal. When you divide by the number, that is the inverse of the number. And when you multiply them, the multiplicative, you get a 1. When you get a 1, it's called the multiplicative inverse. And so if we can extend this sort of idea to matrices, where if you have a matrix A times the inverse, which would be 1 over A, is equal to, now when it comes to matrices, we don't divide matrices, but we can represent this inverse in the following with the following notation: A times A to the exponent negative 1. So when you put that exponent here, negative 1, you're looking for an inverse of that matrix, but you're not dividing. It's just the notation here. And then when you multiply those two matrices, you're going to get the identity matrix. Not the number 1, but you're going to get an identity matrix. So depending on how the size of the matrix, it could be a 2 by 2, 3 by 3, that's going to determine what this identity matrix is going to be, not a 1. So let's take a look at some examples on how to find the multiplicative inverse. In the first example, we're going to look at finding the inverse of the matrix. I'm going to show you, I have a guide here on how to find the inverse of a matrix, a 2 by 2 matrix. And the example that we're going to use is right here, negative 6, 6, 0, negative 6. It's a 2 by 2 matrix. And so let me explain the process, and then we'll apply that process to this example. The first thing to do is to indicate using notation here, negative 1, exponent negative 1, which means that we're finding the inverse of that matrix. And then this fraction here is 1 over the determinant If you forgot how to calculate the determinant, I've placed a link up here for you to go watch how to find the determinant, and then you can come back and continue watching this video. And so we're going to divide 1 over a times d minus bc. This calculation is the determinant, and this fraction gives us the coefficient of this matrix. Inside the matrix, you'll notice that D and A are switched. So A goes to the position where D was, and D goes to the position where A was. Now, C and B, they remain in the same position. The only thing you need to do is change their signs by multiplying by -1. Switch A and D, and then C and B, keep them in the same positions, but change their signs to a negative. So let's apply that process to this math problem. So the first thing to do is to calculate the determinant of the matrix. And so the determinant of this matrix is going to be -6 times -6, that is 36, and then minus 6 times 0 is 0, 36 minus 0 is 36. So that's the determinant of this matrix. And then now we put that determinant in a fraction, 1 over 36. It becomes a coefficient of our matrix, and then we switch A and D. Now the good thing about this matrix, A and D are the same number, so -6 and -6. Now 6 and 0, we're just going to make them negative. 6 becomes -6, 0 is always 0, and then now we multiply this coefficient times everything inside the matrix. So -6 over 36 simplifies to -1 over 6. 0 times the fraction is just a 0, and then -6 over 36 is -1 over 6. So all I'm doing is simplifying. I'm multiplying the fraction times the number and then simplifying it. And then finally, we have -1 over 6 as the final value in our matrix. This matrix here is the inverse of the given matrix here. So now let's check. I'm only going to check for this particular math problem. But if you did this math problem correctly, the steps correctly, you don't need to check. But checking is always a good thing in math, just to make sure that you didn't miss something. So we're going to multiply the given matrix, the matrix that we had at the beginning, times the inverse, the one that we just calculated. And our answer should be the identity matrix. What's the identity matrix? Is the one where the diagonal line here has ones and all the other values are 0. Now, I'm going to go through this calculation here using mental math. Please pause the video, do the calculation yourself to see that you're going to get the same values that I got. So now, when you multiply -6 times -1 over 6, that value is going to be 6 over 6. So 6 over 6 is a +1. When you multiply -6 times 0, that is 0. 0 times -1 over 6, that's going to be a 0. So this second value here is going to be 0. So now we go to the second row. +6 times -1 over 6 is -6 over 6. -6 times -1 over 6 is +6 over 6. So you'll notice that you're adding a +1 to a -1, and that value is a 0. Finally, +6 times 0 is 0. -6 times -1 over 6 is +6 over 6, which simplifies to a 1. So you'll notice that this is the identity matrix, which means we calculated the correct inverse. Let's go to the second example. Second example, we have 5, 6, 3, 6, and we're going to follow the same procedure here. Step 1, find the determinant, convert it into a fraction, multiply by switching the values here, A and D, change C and B to negative, and then that's going to be the inverse. So let's go through this step by step. Determinant is the first thing. So the determinant of this matrix is 6 times 5, that's 30, minus 6 times 3 is 18. You subtract those two numbers, you get 12. So this 12 is going to go in the denominator of our fraction. And then we multiply that by switching 6 and 5. So 5 goes down, 6 goes up there. And then 6 and 3 become negative. And then now I'm ready to multiply each value times the fraction. So 6 over 12 is just simply 1 over 2. And then 1 over 12 times -3 is -1 over 4. And then finally, -6 times 1 over 2 is -1 over 2. And then 5 times 1 over 12 is 5 over 12. And these fractions here are in the simplest form, and this is the inverse. This example, we have -1, 1, -1, 4. We're going to go through this step here again. Find the determinant, change it into a fraction, and then the original matrix, switch A and D, and then C and B stay in the same position, but you make them negative. So determinant is the first thing. Multiply -1 times 4 is -4 minus -1 times 1 is -1. When you subtract those values, you get -3. That's the determinant. Turn it into a fraction, 1 over -3, and then multiply by switching A and D, so switch -1 and 4. So 4 goes up, -1 goes down, and then the other two values, you make them negative. So this -1 becomes a +1, and the other one becomes a -1. And then now you're ready to multiply times the coefficient. So the first value up there is going to be -4 over 3. And then when you multiply 1 over -3 times -1, it becomes a +1 over 3. And then the next value, when you multiply this fraction times +1, it's -1 over 3. And then when you multiply this -1 over 3 times -1, you get +1 over 3. And this is the inverse of this matrix. If you check, you multiply these two matrices, you get the identity matrix. Something to keep in mind when you're calculating the inverse of a matrix is to first of all determine if that matrix can have an inverse, if it's invertible. And we do this by checking the determinant. If the determinant is 0, then there's no inverse. The matrix is not invertible. You just stop the process there by only looking at the determinant. You don't need to go any further. But if the determinant is not 0, then you can go ahead and calculate the inverse. So let's take a look at the process here and understand why we cannot find the inverse when the determinant is 0. It comes down to this part here of the formula. So when you're finding the inverse of this given matrix, the formula here, the coefficient of the matrix involves dividing by the determinant. So AD minus BC, this is how you calculate the determinant. And you'll notice that the determinant is in the denominator. The denominator of a fraction cannot be 0. If it's 0, you cannot find the inverse. So always keep in mind, whenever you're going through the process of calculating the inverse, determine whether or not the matrix has an inverse, and then you can proceed to find the inverse. If it's 0, you stop the process. Well, that's pretty much it. That's how easy it is to find the inverse of a matrix. Remember to subscribe to the channel, like the video, and share it with a friend or somebody that's going to find this content useful. Leave a comment below letting me know which math topic you'd like for me to cover next. And with that, I'll see you guys in the next video. Bye-bye.